Hello, everyone, and welcome to our today's webinar. My name is Susanna, and together with my colleague Peter Martin, we will be your hosts and webinar moderators today. Some of you are already familiar with Experience Controls, the free mobile textbook that Quanser shared recently with the community. And today, Peter will talk more about the modern pedagogy approaches the textbook is built on, and how these approaches could be applied in a broader sense to build a more modern and interactive engineering course. Peter is our engineering curriculum manager at Quanser, and he and his team develop solutions for our academic labs, including all the course materials that come with Quanser hardware platforms for controls, robotics, and mechatronics. Peter has a lot of experience from teaching controls courses as well as working with our clients on developing engineering courses at their institutions.
All right. Thanks very much, everyone, for attending today. This is going to be a little bit of a change of pace, at least for the typical webinars that I'm a part of, in that we're not necessarily going to be as focused on Quanser products or Quanser solutions or the things that you typically see associated with Quanser. This is more of a kind of a general overview of how we as a company, me myself, see modern engineering education, and more specifically how you can change the way that you structure an engineering course, especially for the courses that we typically specialize in terms of controls, mechatronics, and robotics, to really make it more modern, engaging, and effective for students. So just to get started, we're going to talk basically a little bit about engineering education generally, but realistically just that it's not an easy thing to really modernize and to make a course, or even just to educate engineering students, is not an easy task to do. It's one of the more, I would argue, difficult subject areas to really have students engage with and really have them get the outcomes that you need them to have in order to be successful. Because realistically, some of these examples I have here on the slide, this is how students increasingly see engineering, especially coming out of high school in North America. They see rockets landing and space robotics and all sorts of modern commercial electronics like smartphones and drones, and even things like electric cars, or increasingly the drive for students to learn how to code and things like that. And they associate that with the exciting side of engineering, the side of engineering that everyone wants to be a part of. But there's a dichotomy in engineering where that isn't necessarily everything that engineering is. There's a lot of underlying theory and mathematics and rigor that goes into these solutions that students aren't necessarily subject to or exposed to until they get into engineering, which means that they have a different thing they connect with. They want to have that excitement, but at the same time, they don't necessarily have the same investment in the theory and the mathematics behind it. Some do, obviously. There are students who really engage with that side of engineering and really like to do that side of it. But at the same time, we need to appeal to both types of students: the students who really just want to make things and build and get their hands dirty, and the students who connect more with the theoretical side of engineering. And both of them need to be motivated to invest their time and their energy into an engineering course with just the promise that there'll be a payoff, with the promise that one day they'll be able to use these skills to be successful. And so it's that sort of balance that I'm going to talk a little bit about today in terms of how you can structure a course so that it's a little bit easier to show students how the theory meets the reality of engineering, and then also how down the road they can take the skills they gain and really apply them in their everyday lives as engineers to have successful careers. I'm going to start with a quote from Ronnie Coleman, the famed bodybuilder. This isn't Ronnie Coleman here, but he said, essentially, everybody wants to be a bodybuilder, but don't nobody want to lift no heavy weight. Essentially, everybody wants to be the glorious engineer you see on TV or you see on the internet, but but a lot of students especially don't want to have to do the heavy lifting of the theory and the mathematics behind it. And so that's why we have to bring together different approaches to show the students how that payoff is there, how they're going to be able to get that experience, and it'll serve a purpose. Some of the key trends that are starting to address the way that you can give students these experiences and get them motivated are things that you may have heard of, I'm sure, in conferences like ASEE, or we for other conferences focused on engineering education, things like project-based learning, or also problem-based learning is another part of that. Self-directed learning, industrial-aligned courses where industry plays a very tight role in informing the skills that students gain and how those skills are used by students. Experiential learning, which is sort of similar to project-based learning in that students are in project-based learning really having projects form a central core of the course where they build and they experience and they work on a project, and through that gain the skills and the theoretical background they need. Experiential learning is a more broad approach to that, where students just experience engineering, whether it be through videos or through hands-on laboratories or things like that, that aren't necessarily in the project format, but still getting those hands-on skills. And also online learning, which also links a little bit back to self-directed learning, where online resources and mobile resources, more and more things like experience controls that Susanna mentioned, are giving students the ability to have their learning experience wherever they want, whether it's in their bedroom or on the bus or in the cafeteria. They can have online resources to let them look at lectures or other resource materials or have experiences with the course material, even have an entire course with things like MOOCs or large-scale online courses where they don't necessarily need to be in a classroom. And that can then very easily, because it's software, because it's an online experience, link directly to self-directed learning, where they make decisions about the content that they're going to consume and when they're going to consume it and how they want to learn about these particular parts of a course. So all of these elements together form a little bit of the basis of what I'll talk about in terms of the structure of a course that can address these, but also these formed the basis for how we started as a company to address this challenge of how do you bring some of these more modern trends in education to an engineering course, primarily for us, because it's where we live and breathe, a controls course. And so if you're not familiar with experience controls, I'll just give you a little bit of an overview of what we did with experience controls. So essentially we created what we view as being essentially the best controls textbook available. It has all the content you'd expect out of a controls textbook, but it's completely mobile. It's completely native to mobile device, so you can use it offline wherever you are. It has interactive simulations. It has a really rich way of interacting, not just with the simulations, but with content through plotting and videos and all sorts of other interactive elements. We have podcast lectures. We have the ability for you to remotely connect to hardware to get hands-on experiences, all this kind of thing right at your fingertips and in a format that students connect with, because it's where they're comfortable being able to use their mobile devices to consume media and consume content is something that they're very familiar with. And so it meets them where they are in terms of having the experience they typically have with how they want to consume this type of information. And so we started here. This was the nexus or the beginning of what we wanted to do to address elements of a course outside of where we've lived for 30 years in the laboratory. But this raised a few questions for my team once this became successful. Primarily, where do we go from here in terms of being able to recommend a course structure that really complements this approach? And so for me, that was a trip back in time to the controls courses I've taken throughout my academic career, and then also working with our founder, Jacob Abkarian, teaching control systems to graduate students at the University of Toronto. And starting from there and looking at the experiences I'd had, really I started to sort of pull apart the elements of the courses I really connected to and build a structure that I thought made the most sense to address those modern trends I just talked about and leverage experience controls and our renowned hardware that we have in laboratories to really give a full modern experience to students that bridges that gap I talked about at the beginning in terms of giving them hands-on experience, giving them theoretical foundations, but also showing them how these skills will be used in the future and how they can really leverage their experiences to have successful engineering careers. So that being said, the approach that I really connected to once I'd sort of formulated my concept and then talked through it with a number of my colleagues was this concept of a studio classroom, which is a traditional approach, especially in the arts, where students basically focus on project work and experimentation in a single sort of studio environment where it's very open, it's very self-directed. They have the ability to take on projects or take on tasks or challenges that they want to address in an open way with guidance from their instructors and from their peers, but outside of the traditional lecture, lab, homework style format. And so this is primarily focused on replacing or at least downplaying the role of the lecture and giving the responsibility of learning on the students. So the students really have the choice of how they want to learn, when they want to learn, and what they want to learn about. And so there's been some publications in the literature about this topic. It's pretty sparse, but it does exist. And so the concept from what I had pulled together, and this concept of a studio classroom, which one of my colleagues pointed out was essentially what I was describing, we pulled together and formalized into the concept of an engineering studio. This is a description of just the general studio task, which really resonated in as I said, the studio problems that students focus on when they're part of this experience in the arts or whatever the topic is. It holds their undivided attention for a term, so they have the time to really engage with it. But secondarily, the main reason why this is such an essential part of the arts is because it's how they build their portfolio to present to prospective employers. And realistically, for engineering students, they're not necessarily building a portfolio, but they are gaining skills that they can point to when they have the interviews once they graduate. And those interviews are primarily for engineering graduates based on the projects they did when they were in academia, especially for graduate students. And then also, they are building a portfolio of skills, a toolbox of essential experiences they've had where they can point to a programming language or point to a hardware platform and say, yes, I've had experience with MATLAB Simulink or C++ or ROS or whatever it is, and have that as the primary way that they show an employer that they have the experience they need to get the job done. And so this is really the core of why I thought this was really complementary to engineering. And so what we came out of this with was essentially a framework for how you can have an experiential engineering course complemented by the experience apps, the experience controls, for example, and our laboratory hardware that's both aligned with modern cutting edge institutions and trends in engineering education, but also primarily driven by the challenge and operation of engineering R&D. So by that, what I mean is the way that we structured the course that Jacob Abkarian and I ran at the University of Toronto, and the inspiration we've got from studio classrooms is essentially giving students the experience they would have if they were either co-op students or recent new graduate hires at an engineering firm like ours. So what we do is we structure the course as we would structure a learning experience they would have as an incoming graduate student in our department. So we give them the same support, we give them the same resources and the same experience, but they're also called upon to make decisions to have an independence that they would have in the workplace. So they get that experience of having to find resources, having to choose their own direction and path through how they learn about concepts and seek out information, whether it's from colleagues or peers or someone else who has more experience, to get the skills they need to solve the problems they've been assigned. And that's exactly how an engineering firm works. And so to me, it makes the most sense to give them that experience early so they're comfortable in that environment. So the course elements that we've outlined are essentially lecture content is still provided. We're not completely doing away with lecture content, but it's provided outside of the classroom using videos, podcasts, discussions with peers, and that's supplemented by the resources that we have for things like experience controls, where they have a full wealth of content, whether it's YouTube videos by someone like Brian Douglas in the example of a controls course, or the other rich experiences they can have on other video platforms, supplemented by all the material we have in experience controls, including our podcast lectures or other examples of those sorts of resources if it's outside of controls, to get all of the hard information and hard sort of reference material they need. But it isn't necessarily them having to go to the lecture hall for 3 hours a week and sit and listen to an instructor present the information. They can choose how they want to digest it, how they want to experience it, and in what order and at what time they need that information. Laboratory activities are modular skill building activities that are self-prescribed by students. So in that, essentially what I mean is that if students are accomplishing a challenge, they're taking on a part of the course and they find, I really need a little bit more experience than these resources I have from the offline material are giving me. I need a hands-on experience so I can really get a feel for what this means. They can go to the lecture hall, go to the laboratory and get those experiences directly on the hardware, which is at any time, it's open access to the hardware. But the modular activities they do in the lab are self-prescribed. So if I decide I really need to understand how integral windup or filtering works for control systems, I can go into the lab and do a modular activity based on that skill, based on that particular focused outcome, and get that particular experience on hardware, but not necessarily following a monolithic procedure like we would typically do, where you go to the lab every week and you have to go through a procedure and follow instructions and record information. It's more, what are the skills you need to solve the problems you've been assigned, and you go and you get those hands-on skills when you need them. To a certain point, same as the lecture material. Presentations and reports and the course activities are vary from student to student in that they have, again, the independence to create and to present reports and information back to the instructors in order to be assessed as they see fit. So this was one of the main sticking points when we presented the course like this at the University of Toronto, but eventually the students understand the motivation behind it and connect to it. But essentially, we don't give them report templates. They're expected to create reports at the end of every challenge, which I'll talk about in a second, or at the end of their project. But the reports, again, are open to them to just convey the information they need to, because again, that's how a lot of times engineering departments work. If you need to be able to communicate information to your supervisor or your colleagues, you need to be able to pull information together and convey it as succinctly as possible and in a way that resonates with your audience. And giving them a template where you have to fill out a background section, the steps you followed and the results you got, it's make work tasks for the students, and it's not teaching them how you present information in the real world. And so doing something like an executive summary where you just say, this is essentially what I did, this is the outcome and the results that I have, and this is why it shows that it was successful or shows that it wasn't quite successful, and this is what I think I need to do in the future. That's all the instructor needs to know to understand that the student was able to accomplish the task and they were able to do it successfully or not quite successfully. And so it saves the instructor time because they're not reading 30-page lab reports to understand if the student really got the outcome they needed to get and how well they really understood the concepts and were able to succeed. But at the same time, the students also aren't wasting time because they're not creating a 30-page report, half of which the instructor is never going to read. And so it gives them a multitude of experiences, which is why it was something we really focused on in the course. But as I said, a lot of students who've come up through engineering education in the traditional way, it takes a while for them to adapt to it. So they need a little bit of hand-holding and guidance to understand why and what they need to do, because they're going to be emailing you saying, like, I don't understand what I'm supposed to present to you. Do I need an introduction section? Do I need a conclusion? It's like, well, what do you think? Like, what do you need? And then finally, the projects and challenges are industrially aligned in that what this could be, excuse me, this could be a project that is inspired by an industry challenge. It could be a project that's an actual partnership with an industrial partner for the course. It could be a number of things, but again, it shows the students where these particular projects and skills are used in the real world. So it gives them that motivation to address these challenges. Again, so the general structure, this is to a certain extent the order that we sort of generally ran every challenge we had for the course. So the course is split into a successive collection of challenges we give the students, which I'll talk about in a second, and then it ends with a project. And so if you look at the structure here, the projects or the challenges are the beginning of every sprint, if you want to take a kind of an agile Scrum approach or concept to it. Excuse me. The weather's changed here in Canada, so everyone's a little bit under the weather. So these challenges are given to the students, and they look at the challenge they have in front of them, and they think about how can I break that challenge apart and into the pieces that I need to do to accomplish the challenge, and either assign them to a group or do them in a step-by-step manner. But part of it is also, as I said in that A section, you want to retrospect on the previous challenge, the previous experience, so you understand, why did I fail last time I did a challenge? What were some of the things that I struggled with? How can I do it differently this time? And so again, it's a little bit of a part of the Agile Scrum approach, where you're looking at what were the mistakes we made, how can we do better this time? And then you take on that 3-4 week challenge of solving this problem you have assigned to you in a step-by-step way, whether it's, again, going to the classroom to consult with your instructors, have a demonstration of some tools and techniques you might use, going to the reference material where you have your interactive textbook or your online lectures or whatever it is to gain the offline skills and understanding you need, going to the laboratory where you have open access to the hardware for validation of your theories or validation of your concepts, your prototypes, and then also getting more skills. And then finally, the reporting side of it, where you have your assessment and your technical communication skills. So this is sort of the elements of every one of the cycles of the course, whether it's the first, second, or third, or fourth challenge, or the final project. You have the problem, and then you use the classroom and the reference material to figure out how to solve the problem, and then the laboratory to decide if you have solved it, and the report to communicate how you solved it. And that's why I have sort of the 3 dots following this sequence, because this is a cyclic process where you do this over and over again, where you're learning over time more and more material. It's scaffolded so that the material gets a little bit more complex every time. You're applying the skills repeatedly and building new skills that you then apply next time, but also your experiences of what worked, what didn't work, what you need to change next time. So for the classroom sessions, as I said, there's guest lectures, demonstrations, recommendations for different techniques, roundtable discussions, tips and tricks. These were, for me as the instructor or as a co-instructor, the most rewarding part of the course we ran, where we really got to just sit with our students. It was a little bit easier for us because we only had 20 or 30 students. In a larger course that has 100, 200 students, it would have to be broken into subsections where you have teaching assistants running these sessions, which we've also done before for other courses at University of Toronto. Because it's obviously the single instructor can't sit with 200 students in a round table. It'd be a really big round table. But at the same time, you get the experience of understanding what the students are struggling with, what guidance they need, being able to show them a trick or something that they can do next time. The one that I liked the most for this sort of thing was we would do the first challenge where they're doing a model of a particular piece of hardware, and the students would come back on our first classroom session and they'd say that your hardware is broken. And we'd sort of like, why do you think the hardware is broken? And they're like, well, my model doesn't match and my control gains don't work. And it's like, yeah, but you haven't actually modeled the system. And also you just spent a week and a half creating a theoretical model, and you could have spent 10 minutes creating an experimental model. And so you can give them that understanding quickly, but they have the experience of spending a few days trying and finding their own path and understanding the elements of what comes together, so that when they have that interaction, they understand what you're talking about more immediately, and they also understand the ramifications of what you're discussing. And so it resonates a little bit more because they understand where they've been and where they can go. And it's important to do it every week at least, so that they are able to iterate and to advance through the challenge they have for that particular part of the course. Again, laboratory sessions, as I said, open access to hardware for them to gain skills and have reinforcement activities, but also to have a proof of concept and validation of their theories for how they're solving the problems they're addressing. And then we have the challenges and the project, which is the core of the course, where there's a flexible reporting template. It's essentially based on what did you do and how did you do it and what was the outcome. But then also the project condenses the skills that they get over the challenges into a creative application, hopefully industry inspired or at least driven by an industry partnership. So to come sort of back to the beginning and talk about how this looks for an actual course, this is the sort of, as I said, flow of, let's say, a 4-month course, which is more or less typical in North America at least, where each of these challenges would be probably about a month. So the first challenge would be for a controls course, addressing a challenge of speed control, where they're provided with a piece of hardware and they're given a challenge in terms of a set of specifications of how this particular piece of hardware needs to behave. In the first case, for something like speed control, and going through an introduction to control systems and some aspects of qualitative tuning and some aspects of how you actually apply these in hardware in the real world using software platforms like C or Python or Simulink, and on the actual hardware systems, gaining the experience of building a speed controller for a servo system. And then they would have their retrospective, they think about how they did, they'd write their first report, and then they would go into the second challenge, being position control, which is slightly more involved. In this case, they'd also be called upon to do a little bit of modeling and some actual control design, and take into account hardware considerations, things like what the particular sample rates they're running at, how they're getting their data and how they're filtering it and how they're processing it and things like that. And then again, they would iterate again the third time for a more complex topic, in this case, balance control, where your system is unstable and you're using more complex control approaches, things like lead lag and state space, or looking at various control schemes. And then once they've gained all of those skills for the first 3 months of the course, then they take on a project. And it's a pretty accelerated project in the case of a 4-month course, but you could play with the timing. You could have 3-week challenges, in which case you have a bit more time for the project. But in this case, they would do something maybe more advanced, whether it's an advanced control approach or it's something more industrial or something that's a little bit more complex in terms of how you bring those experiences of the course together. But essentially, all that we gave them for our course was guidance that they had to use hardware and they had to show the skills they'd gained in the course. That was but other than that, they could essentially do what they wanted. I think probably for an undergraduate course, you would need a little bit more structure in terms of how the project is presented. For graduate students, we could just give them the ability to go off and create something that they wanted to create. But in the case of the project, it really comes back to the reporting and the presenting in terms of showing the class, showing the industry partners if they're involved, or showing the instructors how they created the project, what the outcomes were, and that kind of thing. And so essentially out of this, you get a really easy breakdown also for assessment, where the reports that the students create for the first 3 challenges could be, let's say, 20% of your mark each, and then a 40% product at the end, and you have all of the assessment as well based purely on the student giving you information themselves and communicating effectively, which they'll have to do for the rest of their career, what they did and what they learned and how they were able to solve the problems that they were given. So in terms of a more kind of discrete breakdown of how this course could look, the topic list here is based on what we have in experience controls, but you can see how the topics get broken down into the different challenges. And then at the end, you have the project, which basically just builds on whether a combination of the previous skills or advanced controls concepts, or something a little bit more special if they want to go off and do something that hasn't been talked about in the course, like sliding mode or fuzzy control or something a little bit more interesting. They might go off and do that as their project. We had all sorts of projects, from students doing traction control for simulated vehicles to medical applications of simulated hearts, so all sorts of stuff. But basically, to summarize, the main thing that we think that this does as an approach is it delivers the types of students that engineering companies look for. If we're hiring students into our company, our mechatronics R&D company, this is the type of student experience that we're looking for in an incoming hire, in an incoming student, especially a recent grad or a co-op. And so if their ultimate motivation is to gain the skills they need to succeed in their future careers, these are the experiences they need to have. This is how they can really excel and really communicate to, in a job interview or in another situation if they already have a position, what they can bring to the table and what experiences they have and what they've done. And I mean, this is again going back to Ronnie Coleman. One of his other famous quotes is, "Ain't nothing to it but to do it." There's nothing, and this is both applies to the instructors in that just give it a shot. Like it's going to be a little bit challenging. I mentioned a few of the things that come together when you actually apply this approach, and we did for several years, where students are going to be have a little bit of trepidation at the beginning, where they don't really feel like they're getting the same kind of step-by-step guidance that they would typically get. But for our voluntary graduate controls course that we had, where students didn't have to come and take our course, we did surveys every year, and the surveys showed that obviously not everyone thought it was fantastic, not everyone really connected with the approach that we took, but every single student said they would recommend the course year after year, and year after year our enrollment went up by a large amount, whereas we started with about 10 students and ended with about 35 students, 40 students, which for a voluntary graduate course is a lot of students. So we were able to show the most important thing for our course, which is students volunteer to take it, and that shows a lot about how they're motivated and how they connected with the course material. But at the same time, again, coming back to the hands-on experience, for students, there ain't nothing to it but to do it. They need to get those hands-on skills, and that's what we think that this course gives them. So I think we'll pivot now to questions people might have in terms of this approach. I'm more than happy to talk more about anything else that you guys like me to focus in on, or anything, questions about what we've done in the past. We have a question here. In your engineering studio vision, how do you see the role of the instructor? So I mean, the simple answer is, for the way that we ran the course previously, the role of the instructor was essentially the same as the role of a supervisor in a department. So you're there as a colleague, not necessarily a colleague, but you're there as someone who can give students guidance and show them the path, and be a consultant or someone who's had experiences that they're looking for. I have a friend of mine who is an instructor for various engineering courses, and for a couple of his courses, he's taken the same approach where he'll give students a challenge, and then as one of the resources listed for the challenge, say like, hey, look guys, I've done this, I've worked in this job, I've had these hands-on experiences, and I am a resource for you. Come to my office, come to our classroom sessions, ask me questions. Like, I've been there. And that's the same sort of role that I would personally see as someone, as a manager or a supervisor, where you go to them and say like, hey, look, I tried a few things, I'm not entirely sure what's going on, and they're able to walk you through what you've done and what you might want to look into to solve the problem, and be sort of that reference that you have as a person, whether it's the instructor or the TA. But also in those classroom sessions, it doesn't just have to be that interactive sort of roundtable discussion. It's an opportunity to have mini lectures, to walk through tools or techniques or specialized applications, to have guest lectures from other instructors or other peers, and give students another aspect, another dimension to their experience. So there's still a lot of opportunity to be an instructor and to present to students, but it sort of downplays the traditional requirement for you to be in a lecture hall in front on stage of the students for hours a week, presenting step by step the material that they could essentially just read or digest themselves. It's more of an interaction and more of a collaboration to get them the experience and the guidance they need to see what they need, the direction they're going in. Can you cite institutions you know of that have implemented this approach? What are the challenges departments have experienced in transitioning to this approach? And the change in the role of the instructor would certainly be one example. Yeah, the change in the role of the instructor is definitely an example. It was easier, I'll readily admit, for Professor Carrion and I, because we were coming in both to a graduate level course, and also I had not as active year after year after year instructors. At the same time, both of us had taught courses in the past, and it was a little bit of a change based on our experiences. But again, it was informing our experiences based on having been in industry for several years. Other institutions, as I said, there are aspects of this that I know of that colleagues of ours have been doing, especially in the collegiate level here in Canada. There's an article that I wrote in our blog, I believe a couple of weeks ago, that talks a little bit about modern trends in engineering education, and it references a document that was created by MIT last year on current trends in modern education, modern engineering education, and that has a whole realm of different institutions that are taking on different aspects of modern course design. The one that I know is similar to this approach is Enmite in the United Kingdom. Is taking an approach like this. There are elements of this that we've done in partnership with York University in Ontario, where their instrumentation and measurement course has been structured in a similar way, in that a lot of it is project-based and a lot of it is hands-on. But again, this isn't necessarily saying this entire approach needs to be swallowed whole. You can definitely take portions of it and take different inspirations from different elements of it and apply those as separate examples. It doesn't have to be the whole thing all at once. So there are definitely examples of different places where this is happening, but to be honest, outside of the experiences that we've had and some of the experiences that we've heard about from some of our partners, I'm not entirely sure. I know as I said, the actual concept of a studio classroom, it's a little bit sparsely published, but there are examples, if you look at those references I had earlier, of studio classrooms outside of the arts. I think the one that's mentioned there was a geoinformatics course or a geophysics course, and so it is being used in that structure outside of the arts in other non-engineering based departments. I heard the term flipped classrooms. Is this an approach you just presented in the flipped classroom model? Yes, this is one of the elements of this approach is taking on a similar approach to a flipped classroom. The flipped classroom, to me, it needs to be complemented by this type of approach. I think just having video lectures for students and an in-class tutorial, it leaves a little bit in terms of students not feeling like they have the materials and the experiences they need to be able to succeed in a course. And so thinking about flipped classrooms, to me, this is how I would flip a classroom, not just with the lecture and resource materials being outside of the classroom and the interactive experiences being in the classroom, but in terms of the amount of time. I had a conversation recently with an instructor who was saying that the problem with flipped classrooms is students feel like, as opposed to having lectures 3 hours a week, all the emphasis is on homework. So now they have to do all this homework, and they have all this responsibility to do all of these at home or outside of the classroom studies. And that's true, but there's sort of a requirement that the time that is devoted to the course is still the same amount of time. So as opposed to a 3-hour lecture, you have a 1-hour classroom session and then 2 hours that students, they have to do on their own time, but it's the same amount of time they would typically have in the course. You're not losing course time or gaining course time. It's just, you don't have to sit in the lecture hall. And so, but at the same time, I do feel that students with this type of approach to a flipped classroom might connect a little bit more to the content and connect a little bit more to the resources they have available and how they can use them, especially again with the instructor, that the instructor is available to them and able to answer their questions. For our courses, this is not something I would necessarily recommend for large courses or even for a lot of courses, but because we were running a smaller 20, 30, 40 student graduate course, they all had my email address and they would email me questions all the time. It may have been a mistake, but that's how we did it. And to me, it was just making sure that they understood that we were available to them as a resource. And it was not just that they had to kind of ask a question after class. How about graduate students? How can graduate students be a part of the instructors with practical solutions they developed or are working on? Absolutely. I think involving graduate students is great because, again, just like I said earlier, where there are different students who connect with different parts of engineering. There are ones who really want to build. They want to build robots and build rocket ships and be the makers. There are also engineering students, as I said, who connect with the theoretical side. There are just as similarly a lot of undergraduate students who want to have a career on the factory floor, maintaining and building assembly lines and things like that. And there are students who want to go to grad school and be a researcher and be a professor or a researcher for their career. And so I think bringing in a combination of graduate students to give them those types of experiences and those types of insights and industry experts, that gives a little bit of a balance of the types of places they can go with their career. And also even breaking the challenges and the projects apart by saying, hey, if you want to do a project where you just write a conference paper or write something as an example of how you might do a particular approach, that's great. Like we had when I was in undergrad years and years ago, we took a fuzzy control course, neurofuzzy course, and our final project was structured in a very similar way where we could do either a hands-on project where we, for instance, built a smart traffic lighting system or things like that. But a couple of my colleagues just did a straight algorithmic search assessment and were able to publish it in a conference paper. So, I mean, you can take different approaches and appeal to different students. And I think involving graduate students is an excellent way of doing that. Sounds excellent for higher level course. For lower level courses, do you think this approach would work? How would you prevent gaps in fundamental knowledge if the learning tasks are student driven? Yeah, I mean, that's definitely a concern. And again, I have to be very clear that I have not personally used this approach for a undergraduate course. We've used similar approaches where we've run controls courses for mechanical students that were based on different laboratory sequences where they were getting hands-on experiences and then culminating with a project. I think typically the approach that you could take to start an undergraduate course for lower level students would be to just include a project element where they're able to take the skills they've adopted and apply them to a project. That's similar to how they run the measurement and instrumentation course at York University that we were a part of, where at the beginning, we come in as Quanser and we do some presentations to give them a little bit of background on the skills they're going to learn. And they do a series of very involved laboratory sequences where they gain skills week after week in the laboratory, reinforced by traditional lectures. And then at the end, they do a multi-week project that they present to about judges from Quanser and from other institutions and other groups. So they kind of do the balance of they still have traditional lectures, but there's a larger emphasis on the lab sequences and the lab activities, and there's a larger emphasis on a project. So again, it doesn't have to be the whole self-directed plunge where students choose their own adventure. I don't think that it necessarily would be prohibitive, but I understand that there's an obligation for students to succeed, and so it's a little bit daunting to take on such a fundamental change in how you would structure a course. And again, I mean, there are different ways to take on different portions of it, or again, depending on the type of institution. There are institutions out there doing this in the undergraduate level, but the outcomes are a little bit unknown at this point. Does this approach fit with dual study? Absolutely. I think this is a great approach for dual study where, again, if the challenges are challenges that students are facing because of a dual study environment where they're in industry, that's a fantastic way for them to gain those skills. Some of this was, again, based on giving students these skills that they would get in a program like the University of Waterloo, for instance, does here in Ontario, where there's a huge emphasis on co-op, and students spend months and months and months of their undergraduate years in co-op cycles and rotations. Same at the University of Toronto, they have full year co-op programs. It's trying to give students those experiences without needing to necessarily be a part of an institution that has a co-op program. So if students are in a co-op environment, they have full self-directed environments where they can gain these skills. And this was just sort of an attempt to try to bring that into the classroom. So I think it fits perfectly, absolutely. Are you available to partner with teams in the United States on proposals to promote educational activities? How would that typically work? Yeah, absolutely. In terms of proposals, if there are proposals for things like educational grant funding and things like that, we have a team dedicated to collaborating on grant proposals and opportunities. We have a lot of experience, especially with NSF grants, on how to formulate and how to create a grant proposal that would be successful in culmination with our hardware as a backbone to the hands-on experiences and things like that. I know because of my involvement in managing parts of the experience controls development, there's a lot of opportunities out there, especially in the United States, for funding centered around activities on modern approaches to engineering and education. And so whether it would be a more dedicated approach to that kind of thing, we definitely have a team that can help with creating grant opportunities that work for you and for us as an institution, and really being able to formulate that. Absolutely. There's one question: what is the main idea of the webinar? So the main idea of the webinar series I might talk about a little bit, which is this is the first of what will hopefully be a series of webinars sort of centered around the different things that have come together in the Experience Controls app. So if you haven't already, I'd encourage you to sign up for the Experience Controls newsletter, which is available along with the instructor material for Experience Controls. And then out of that, what we've started doing with the newsletter for Experience Controls, which I'll mention has a longer blog style article on this topic where I go into a little bit more detail. That particular newsletter, we tried to pull together essentially a collection of topics and blogs and videos we think are interesting to instructors or educators who are have resonated with the Experience Controls approach to modern education. And so this webinar has sort of come out of that, where we're going to do a series of webinars centered around not necessarily Experience Controls, not necessarily controls education, but again, the different elements of engineering education and elements of how we're applying these skills and the things that we do as a company. So for instance, again, now that with Experience Controls, we've taken our 30 years experience with engineering education in the lab and extended that outside of the laboratory environment into the rest of the controls course, and also to a certain extent other courses. And we're involved in multiple projects around the world, developing new approaches to how you teach engineering, whether it's drone design or different elements of other topics, self-driving vehicles or artificial intelligence. We're thinking more as a company about how we would see these different elements of what we do come together in different courses and in different institutions. And so this is the first webinar in that particular series. To be perfectly honest, I'm not entirely sure what the next webinar will be focused on, but it will be a series that will be directed at an audience that is interested in modern approaches to engineering education.
And maybe as a part of your questions or email after the webinar, you can send us your ideas, what you would be interested to discuss when it comes to engineering education and modern approaches and stuff like that.
Absolutely, 100%. My team specifically, we live and breathe these topics day in, day out, and so we're always more than happy to hear from you about what you think is important or what we're missing, or the different trends that you see and how you're trying to embrace them with your courses. This is what we do, so we'd love to hear more. So so compared with traditional teaching, this model adds burden to students' homework. Are there any estimated time in hours or percentages, and how much more time is a burden to the student in terms of self-work? So I talked a little bit about that in terms of flipped classrooms. To me, I don't necessarily think there is more of a burden to students in terms of homework, because if you think about a traditional course, especially a controls course, you could have, let's say, a 3-hour lecture per week, or a 1.5 or a couple of 1.5-hour lectures per week. And then you would have a laboratory sequence following that, and then the laboratory sequence could be between 1 and 3 hours, and then also problem sets and homework and things like that. That's a lot of time devoted to a single course. It could be anywhere from 6 to 8 hours a week of time for a single course if it's a really involved course. And if you slim down the lecture and the lab requirements to be, let's say, a 1 or 1.5 hour in-classroom session the students can come to voice their concerns and talk to their peers and their instructors and get a little bit of guidance on how to solve these problems, or to come to a guest lecture or have a demonstration or things like that. That coupled with, that basically leaves 5 or 6 hours a week, depending on the course, where, yeah, they're not in the lecture hall or in the lab, but they're still working on the course, but it's just of their own volition. And so there is a responsibility for students to put that work in, but it's not any more time devoted to a course than they would typically have.
And I would call this a last question. So thank you everyone for joining us today. Thanks, Pete, for great presentation. Please, if any other question come to your mind, feel free to email us, follow up with us in any way, and we will be more than happy to answer those questions. If you are interested in giving Experience Controls app a try, you can find it on App Store or Google Play. And of course, you can go to our website and request the instructor resources. Thank you very much for your time and see you next time.
Thank you very much.